who had a background in JavaScript, and they were asked firstly to describe what, in their own words, what they saw in specific visualizations that were trying to teach a concept. For example, printf, or for example, showing text to screen. I had a visualization and we had to figure out what's really happening. So also there's to be a test of participants' current knowledge in programming. Then 6 separate tutorials of programming concepts were introduced sequentially. Users then rated their own understanding of these tutorials, and users were then asked to write code similar code as a solution to a similar problem presented in each tutorial. So from the test before and after, we can apply some statistics, namely the peer-to procedure, to analyze the data to see a mark of how beneficial, if it was, this concept. Also, Bloom's and the Solo taxonomies are used as a basis for the participant tests. So I know what the tests are testing about learning. Research findings. For the visuals, 10 out of 10 users understood printf visual, which is how to print the screen. 10 out of 10 users understood what declaring, initializing a variable that visual did. 8 out of 10 understood calculation with variables. 7 out of 10 input into a variable from the keyboard. However, for 3 out of 10, this was a bad result for the loop visual. 7 out of 10 for the if condition visual. So overall, I would give this I would suggest that these visuals are successful, except for the following. Empirical evidence. All users reported the tool was helpful, and they felt they learned programming. And these are some of the comments that I have here. Boosted my knowledge, made the concept simple. Someone even asked, I think more than one people asked for a copy of the program, they were begging me for it. And usability issues. Users complained that they could not go back and line the tutorial. Also, all users agreed, however, that a stepwise approach was user-friendly and easy to follow, which was very important. Concept issues. Users needed more information about the programming concept. This is something that they complained about. Some concepts had insufficient information. Discussion. 9 out of 10 of the participants rated their understanding of the concepts after the experiment at a mode of 80%. All visuals expressed the concept correctly, except for the for construct. The tool did not provide sufficient information, and empirical data from the experiment suggests that enough information about the concepts was not provided at the appropriate time. Conclusion and recommendation. Findings suggest that the techniques used in learning by example code provide a valid alternative to tutoring approach. Visuals' illustration of semantics of source code successfully fostered learning. The stepwise example code successfully supported learning by doing, because they reported that they all users agreed that the stepwise approach was user-friendly and easy to follow. This was important to me because it helps answer one of the objectives at the start. And because of this, there's very good reason to conduct the formal research and keep iterating. References and just to show you a very quick demonstration. Use case, a lecturer could probably write up a C programming code, an example code here to do something specific. And they say they did it in their favorite ID, their C++. Now, I'll run the tool just to show you the visualizations quickly. I'll open, this is the file that I showed you just now. So what it does is read the lines, read those lines, and it instructs the user. And here is an explanation of the line of code. So for this assignment, what the engine does is reads 9 and shows a visual of the variable here, the container, with the number going inside. And this is not hard coded, it's actually dynamically generated by parsing that line. And it keeps a trace table, it knows that X is 9. So now we declare Y, it's empty. We do a calculation where Y, which is empty, is assigned to X, which is 9 plus 7. Which should be 16 if I'm not correct. So it grabs from the trace table what X has, adds it to 7, gets the calculation, and puts it into Y. Now I'll just try a loop. So this visual tries to explain the loop in detail, what to do first time only, what to check before running each block of code, and so on. And it calculates, it actually calculates the amount of time this code will run. If we change this code, it will calculate it. Lastly, if this just does a calculation. But this is a drawback because this is a flaw because this is in a loop, but it doesn't cater for the loop. It only shows one calculation. And the printf, it shows the user a monitor with letters on it, and almost all the testers figured out, okay, this is some text that will show up on a monitor screen or something, so they got the concept. The flaw with this is that if I have the %d, in future iterations I like to get the value of y and place it right there. I'm just using sharp notes in case people want to know how to type it. So it says you can try and compile and run this code, and I can compile successful. It also caters for errors. Compile, run. So it allows the user to see what they have created. And what was notable in the test, in pilot test, is that they would look at, the users would look at this, they felt inclined actually to look at this and then look at the code and see which part of the code is doing what. And they were asked also to go back and change code if they wanted to. And almost every one of them did. And I believe that helped to foster learning. So there are many other features here.